Hello everyone, welcome to Zaref Game Dev. In this video, we are going to create a simple hyper casual game as we did it in the previous two videos. And if you want to see how those games turned out to be, you can watch in the playlist, which will be shown at the end of the video, and also how the game looks. You can also see it at the end of the video. And the files for this project and the initial resources we are going to use, I am going to share the GitHub repo, which is going to have all the files and the finished project. So let's start creating. So as you can see, I opened up the basic Unity project and named it Tricky Corners because that's what the name of the game is. And this game, I found it online from the Shapeshift Studios. You can search it. He has so many, like, if you want any inspiration or some different types. So, all the games are almost similar, but the mechanic will be different. So, that's for the game. And let's first change our build to for now we are only going to use Windows. If you want mobile, you can change it to mobile. So we'll first uninstall all the unnecessary packages, so because it will slow up our Unity editor, and also when we save our code, it will recompile all of the packages or somewhat like that. But finally I thought it is good to remove all of the packages. So that was the JetBrains editor. We don't need it. We are just going to use our Visual Studio editor. Let's upgrade our Visual Studio editor. And for 1 or 2 minutes, we are just going to like set up our project. So if you want to see how we are going to create, you can directly skip, not update. We need to remove it. So version control is also not needed. We are not sharing our project with, I mean, we are not creating the project with multiple people. So it's directly just shared by one person. So we'll remove it. I think it's going to use for Plastic SCM, which is like GitHub for Unity. It helps us uh, merge our code and all the different things, but we are not going to go into that. So we'll also uninstall version control. See, as you can see, it took almost 30 seconds to uh, recompile all of the packages and all. And in the end, if you like don't use any of the settings and build the game will be almost 40 to 50 megabytes large. But if we remove all of the packages which are unnecessary, visual scripting, which is the largest one, then it will be around like 15 to 20 megabytes, almost half the size. And as you can see, the only packages we are going to need is the 2D, Text Mesh Pro, Timeline, and the basic UI. And we'll remove our Visual Studio Code editor. If you are using VS Code, you can remove the Visual Studio editor. Just have the only editor for which we are going to use. As we change the build settings to Windows, there is one more package which automatically changes. We change to Windows, Mac, Linux. So that's for it. We are not going to go into package. Now let's see what we are going to do with the scene. So first I will import all of my assets, which are going to be from my previous game, Rotate Dash, which includes the editor, prefabs, resources, and the scripts. And I'll just directly bring it inside my Unity editor. So these are all of our packages, includes the animation and the obstacle and all whatnot. And obstacle and the target we are not going to need, so I'm just going to delete it. We'll create it afterwards. All of the rest is the same, but let's also bring in our scenes. So there are two scenes which are the gameplay and the main menu scene. We'll also bring it inside our scenes folder, and let's go to the main menu scene and let's import the text mesh pro essentials. And first we need to check if our all of our imported code is working fine. So this is our main menu. There's a problem with the, I don't know. Let's first go into project settings and disable the warnings for our text mesh pro, or else it will always tell us that some of the characters are missing, and as you can see it is showing the underline is missing. Let's just disable the warnings. Now our game should be fine. The text and everything is working correctly. Now let's hit play. I think there should be some problems as we deleted. So we'll see it afterwards. So let's see if there is any problem with the main menu first. So the sound is working. There's just a problem. No, all it needed was some refresh. So this is our basic setup. Now our colors, I think we'll need to add my color from the previous game which I have created. So let's go inside assets editor, and I'll delete my editor here and bring in the editor from my previous game. I mean the previous version in which I have created. So now if I go inside our main camera, and for the color I'll be get the red color, and it doesn't need to be red. Actually it's going to be white, but our text and all of our three buttons are going to be red color. So play sound and quit, and everything's going to be similar, so it doesn't matter whatever you like. And instead of title of rotate dash, we'll call it tricky corners. What did I paste? So the game name is Tricky Corners, and we changed it to Tricky Corners. So now I think it's a little bit larger, so we'll decrease the size to 80 so it fits perfectly. So this is going to be our main menu, and inside our script similarly we are not going to need the obstacle script, and our main menu scene should be fine. So that was just for the main menu. We finished it up in 8 minutes. If you try to create it again, I mean from scratch, it will take more time. So always reuse your code and know how to reuse your code, so it will help much better. So now we'll go inside our gameplay scene. So as you can see, there will be a couple of errors, so let's delete everything. We don't need the BG. I mean, we will create the BG, but for now we don't need anything. And for our player, we are going to edit our player. So the first thing, it's going to have the image as the bar, and our bar is like have the anchor point at the bottom. So we'll change the anchor point for the bar, nothing else. Instead of pivot to bottom center, we'll just directly set it to center and just hit apply. Now inside our player, we'll set it to bar, and size it's going to be what size it was. So let's first set its position. So it's going to be a 2, -2, and its size is going to be similar. And instead of circle collider 2D, we are going to attach a box collider 2D. And size similarly, we need to set it to 0.64 by 0.64. Move up, move up. Rigid body is going to be similar. So where is our box collider 2D? Move up and before our box collider 2D. And we'll need to edit our player script. Missing prefab doesn't need. So this is going to be our player. And now let's create the background. So our background is going to be, where is our main camera? There's not any problem. So our background is going to be our reddish color and our player is going to be the white color. And after that, our text is also going to be white color. So score and banner text, let's set it to white color. And this was for the scene. Now let's see how the end panel looks. So similarly, it's black. We need to set it to the red and change all of the text color to white. And our score is also going to be, I mean, you can have it as a different color, but we'll set it to white. And our best, it's going to be darker red, which you can already get it from the swatch, or maybe you can have it as gray. Let's, for consistency, let's everything as white. So this is going to the end panel. It's going to be similar. We don't need to do anything to that. And let's hide our end panel. And this is going to be our scene. Now let's create our background, which is going to be reset, have a sprite renderer component, and the sprite we are going to use our bar sprite, and the angle is going to be 45, and instead of simple we'll set it to sliced, which is going to be 8 cross 8. And we'll need to increase our camera size, so it's I think should be around 12, maybe higher, 16. 12.8, yeah, 12.8 is fine. So this is our background. Its color we are going to set it to a darker gray, and order in layer it's going to set to the lowest one, which is the -5. Now I will duplicate this background, parent it to the bg, rename as the center, and change the size to 4 cross 4, change the order in layer to, what should we set its order in layer, -4. And after that change its color to red. So this is going to be your play area, and that should be it for the background. Now it's going to have a tag of obstacle, because whenever it hits, the game's going to end. Let's attach a box collider 2D, and we'll start editing our box collider 2D. So the size is 4.4. Let's duplicate the center, remove that, and change the size to 1.8. Change the exposition to 4.5. So this is going to be our boundary 1. And similarly, its tag is going to be obstacle. Now, uh, when we duplicate our project settings editor and the prefab naming, we need to set it to underscore, so we don't have to name it every time. So as you can see inside the project settings editor and the game object naming, we'll just set it as it is. Now let's duplicate the boundary 1, make it -4.5, duplicate the boundary 2, 0 4.5, and let's rotate it by 90 degrees. And similarly boundary for negative 4.5. So if you select the BG, this is going to be our boundary. Now there is currently no obstacle, and we'll need to create our obstacle. So let's create an empty and we'll call it point. Let's reset its transform, and I think, yeah, that was nah, I did it. So this is going to be our point. Its tag is going to be score. Now we'll need to attach a sprite render component, which is going to have the sprite of bar, and its size is going to be zero point 0.4. And after that, its order in layer is going to be 1, so always at the top. And we'll need to attach a box collider 2D similarly, which is going to have a size of zero point 0.4, which is going to be trigger, and animator component, which we are going to nothing else. We'll just save it as a prefab. And let's edit our explosion prefab. So restart. As you can see, there are explosions, but what we need to do is duration, everything is same, but the start size is going to be different. So it's going to be 0.1 to 0.4 was the size of the obstacle, and it was 0.2. So what was, yeah, 0.4. So 0.4 was pretty much larger. So I think emission and the shape both are good, but for the emission count, we need to decrease its count, which is going to be, instead of 20, let's just set it as 5. And texture sheet animation, instead of knob, we'll use our bar. So if we hit restart, we are going to see squares spawning around. So that was our player, and that's going to be our player scene. Only thing we need to do is, let's first add an animator to our point. So let's go inside our prefabs, bring in the point, and we'll create an animator controller, I mean. So it's going to be AC under slash point. Make sure use the names correctly. So actually it was score, but we already had a score, so I need to rename it to point. Now let's open up our point, and we'll also need an animation window. So this is going to be our animation window. Uh, there is nothing much going on right now, so we'll create an animation which is going to be an point and a slash start. And here let's set the sample size to 30, and for now we'll rescale our animation window, and let's select the point. Let's set the loop time to off first, and we'll add a property for the scale, and let's decrease it to uh, 0.1 second, which is 3 frame. And currently we'll just set the starting to 0, so it scales from 0 to 1. Now after that, we are going to create one more animation, which is going to be an under slash point under slash destroy. So again, it's going to be 30 frame animation, which is going to set up the scale. Did we add the property? Yeah. So the property is added. 30 frame animation, 3 seconds, and it's going to do reverse. It's going to set the scale to 0 at the end. And let's hide our console error. So these are going to be our two animations which are going to play at the start and the end. Now we'll need one more animation which is going to be playing at the runtime. I mean, it would be the default animation, and here what we are going to do is instead of scale we are going to use the rotation, and currently it is at 0. At the end we'll set the rotation 0 to 360. So as you can see it goes from 0 to 360, but it is like a little bit choppier. So mm, 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 we'll need to set it to constant speed. So let's just have it point here, and let's select this point and let's have it point here. Now let's set a transition from the start to the rotate, which is going to be an automatic transition with no conditions attached. So it will automatically change from point to rotate. And whenever we spawn the point, it's first going to start the start animation, and finally it will show us our rotate animation which has a loop time. Destroy doesn't have a loop time. So that's it for our obstacle animation. Now, to check if our game is running, the first thing we'll need to do is have the movement for the player, and we'll spawn the obstacles later. So we'll first comment out the spawn level code, and we'll check if our end condition is working fine, which is going to be the end game. And after that we'll add the code for spawning our obstacles. So let's go inside the coding part, and as we already done before, most of the code we are not going to change, and our obstacle script is removed because it just contains only some animations, not any uh, calculating movements, so it was not necessary. So we just have 5 scripts, of which 4 of them, I mean all 5 of them are created, but the player logic is going to be different. And let me reload. Inside our game manager, the spawn logic is going to be different. So let's go inside C# player scripts, and there are so many things. So what we need to do is let's just remove the whole script. We'll create it from scratch. And if we go inside our game manager, what we'll do is we'll comment out the spawn obstacle. Private transform obstacle not needed. We are going to directly create a game object, obstacle dot transform current rotation, new rotation. I mean, spawn obstacle, the whole content is going to be different. So wherever there are no problem. Everything working perfectly fine. So now only thing we need to check is our trail working fine and our scene is working fine. So as you can see, we deleted the spawn level and our player logic is completely different. I mean, we have not created, and this is our scene currently right now. So if we go from the main menu and open up our scene, there should not be any problems. And first thing we need to do is add both of our scenes to the build. So this is our main menu and this is our gameplay. And now let's first see if we can open the gameplay scene. So with the play, and now if we move our player, so let's have it move. I don't know why it's rotating, but it doesn't matter. Gameplay could not be loaded. So everything's working perfectly fine. There's not any problems except for our player. The color needs to be white and the final transition needs to be different. So I think it should be color over time. We don't need it. So it will always be white. And everything else is similar. The start size instead of 0.32, let's set it to 0.16. Maybe let's just have it at 0.32. Let's save the scene and let's go inside our main menu. So as you can see, everything was working fine, and if we hit the obstacle, our game was going to end. Now let's start coding our player script. It's going to be easier. And that's the only script we are going to have. So first thing we are going to need is using Unity Engine dot collections, because we are not Unity Engine dot collections, system dot collections. We are going to use a coroutine. Let's first have a serialized field, private game object, and explosion prefab, which is going to be shown at the end. Serialized field. Why is it showing private vector3 array? And it's going to be array for the directions. So in which direction we are moving? So we are only moving in one of the four directions. Serialized field, private float, start speed, and after that we have private float speed, private int speed magnitude, which is going to uh, tell us if we are moving clockwise or anti-clockwise. Depending on that, we'll change the direction. Private int speed index, and it's going to be index for our direction. So it will no we don't will not store the mm, mm, how much time is it? 27:50. We are not directly going to store the direction in a vector3. We'll store an index, and depending on the magnitude and the direction index, we'll get it from the direction. So instead of multiplying the direction, we'll change the parameters. And after that, we have a serialized field, private audio clip, and first one's going to be move clip. And we can call it whatever like, which is going to be point clip, and the final one's going to be loose clip, and last one is going to be private animation clip. And it's going to be the destroy clip, which is going to be called on our point game object, and inside of awake we'll set the speed to be our start speed. Our speed magnitude is going to be 1, and our speed direction index is going to be 0. So this is going to be your start speed. And after that, inside our update, if we are getting the input get mouse button down of 0, we'll get the speed direction index, we'll add our speed magnitude. So it will change the direction, and then we'll check if our speed direction index is equals to -1, then our speed direction index is going to be directions dot length -1. And after that, our speed direction index is equals to directions dot length, then speed direction index is going to be 0. So it's just going to check for the bounds, and after that what we will do is audio manager dot instance dot play sound, and we are going to play the move clip sound. And inside our fixed update function, we'll just let's first get the transform dot position, and after that temp plus is equals to speed multiplied by speed magnitude multiplied by time dot fixed delta time, and finally multiplied by directions for our direction index. And transform dot position is going to be equal to temp. I mean, you can put it inside just one code, but it would be better if it is different. And finally, we'll create an on trigger enter 2D if collision dot compare tag is going to be constants dot tags dot obstacle. First, we'll check if it's colliding with the obstacle, then we'll end the game. And after that, if we are colliding with a score, then we'll score the point. Let's add the return and return in both of here. Now, what would happen if we collide with an obstacle? So we are going to destroy that obstacle and play the animation. Now, obstacle means we are just going to end the game. So game manager dot instance dot end game, and audio manager dot instance dot play sound of the loose clip, and we are going to instantiate our explosion prefab at transform dot position quaternion dot identity, and we'll destroy our current game object. So this is going to be our end game. Now inside our score, what we'll do is first we'll update the score game manager dot instance dot update score. However, it will calculate, it depends on it. And after that, we'll start the coroutine. And we are going to, audio manager dot instance dot play sound point clip. And finally, if random dot range from 0f till 1f is greater than 0.6f, then will multiply the speed magnitude by 1. And the coroutine which we are going to start is going to be private enumerator, and we'll call it play collision animation, and we'll get a parameter for the game object target. And let's first set yield return null, and we'll pass our play collision of animation, and we'll pass our collision dot game object. Now, what is going to be inside our collision animation? So we'll first get the target dot get component collider 2D, and we'll disable because we don't need any more point triggers. And after that, we'll get our animator, which is going to be target animator. Then it's going to be target dot get component animator, and target animator dot play destroy clip, and instead of yield return null, destroy clip dot name, and instead of yield return null, We return new wait 4 seconds and it's going to be destroy clip dot length. So that should be it, and at the end we need to destroy our target. So it should be working fine. And let's see if it works as we intended it to be. And let's go inside our gameplay scene. There's an error, so let me see where is the error. So there was just an error with one of the closing brackets. It has fixed. And as you can see, I mean, you won't be able to see, but whenever I edit some of the code and come into Unity, it takes a little bit of time to compile and just compile that code. And let's go inside our gameplay scene and let's go inside our player. So for the player, let's add our explosion prefab. There are going to be 4 directions. The start speed, let's add it as 4. Move point. So where should be our destroy? Yep, there's our destroy, and let's add our sounds. So that's the sound for the move. Update is going to be for the point, and lose is going to be for the lose. Now are we inside Unity? Yeah. What directions are we are going to use? So the first direction is going to be anti-clockwise. So it is towards the right and the up. So right is +1 and up is also +1. Next we have the -1 and 1 because it's left and up. And then afterwards we have right and down, which is going to be both -1. And finally we have, I mean, right, 1 and -1. And okay, so left, which is going to be -1 and 1. No, this was this direction, which is going to be right and up, so 1 and 1. Next it was left and up, and afterwards it is left and down, which is going to be third direction. And finally it is right and down, so 1 and -1. And instead of directly setting the directions, we need to have the direction dot normalized, or there would be like we won't be able to exactly calculate the what the speed is. And I think we should be able to start and end the game instead of having the obstacles colliding. And there should be a problem with our nah, it is perfectly fine. So let's go inside our main menu scene and let's hit play and let's see if there are any more bugs. So we are able to move, and there's a problem with our particle. It is not set to bar. And let's see for game ends. So yeah, it ends, but uh, we have not set all of them to trigger. So let's go inside our main gameplay. And what problem was there? First with the particles for our player, which didn't had the texture sheet animation set to our bar. And similarly, as you can see, it's already 45 degrees, that won't be needed. And all of our this what do you call it, as all of our boundaries or obstacles have been not set to trigger, so that was the problem. And it should be done. So getting errors is good, so you need to know what the problem was to solve it. And after some time for the practice, you should be able to clear it yourself. So that was it. And after that, let's see for game ends. So our game ends again, there was a problem with our another particle. I think it should have some coloring. And let's rename this particle first. So we'll just call it explosion. And as you can see, its start color was different. And again, the size is too much large, so we'll change its end size to be around. This size was fine. Our particle size was different. So let's go inside our scene and let's go inside our gameplay. And for our player, our particle size needs to be constant. So instead of 3D size to 0.32, we'll just set it to zero point 0.2. And now let's hit play and let's see if our player is moving perfectly fine. So we have the move sound and everything's good. Now the next thing is just going to spawning our obstacles, which is just going to be one function. So let's go inside Visual Studio, and as we already created our obstacle or our point, we'll just directly add a serialized field, score clip, max spawn offset, both are not needed, and score, high score. There are not any problems. Sound image is also needed. Private and score is also needed. Now, what we need to do is whenever spawn obstacle is called, it's going to be inside our start function and our update score function. So let's call our spawn obstacle function. And here we are going to spawn an obstacle. So it's just going to be a game object. So let's create a serialized field at the end. And it's going to be private game object and point prefab. And currently I think our point prefab was rotation was different, so maybe we'll set its rotation and let's set it to positive 55 45, so its rotation doesn't change. Now there are going to be couple more variables we are going to need, and the first one is not first one. After that, we are going to have a serialized field, private vector3, and we'll call it spawn pose. And if we select any of the spawn position at random, which is going to be an array, it will spawn at that position. But what we'll do is we'll get a direction to the next spawn position and we'll spawn in between that spawn position. So let's see how we are going to do it. So let's first get our spawn index. So int spawn index is going to be random dot range from 0 to till spawn pose dot count, spawn pose dot length, and after that float position is going to be random dot range from 0 till 1. And don't forget to add the f or it will just take it as an integer. And let's first get the offset, and it's going to be spawn pose for spawn index plus 1, and we need to percentage by spawn pose dot length. So if it is the last one, it will automatically set it to the first one, and after that we'll subtract our spawn pose dot spawn index. So after having done that, let's create our spawn position and we'll just rename it as temp. And what we'll do is spawn pose at spawn index, and we'll add our position multiplied by offset. So if we directly add the offset, it will go towards the next spawn position. But if we multiply it by a factor, which is a random, it will like spawn in between that positions. And what we are going to do is instantiate our point prefab at the temporary position, and at our point prefab dot transform dot rotation, so it does not change its rotation. And that should be it for the code. Now all we need to do is inside our game manager, I mean there should be some problems, but we'll see how it works. And let's go inside our gameplay scene, and inside our game manager, let's first add our spawn prefab, point prefab. And for the spawn positions, let's add 4 of them, and the first spawn position is going to be at 40, which is the right one. Next is at 04, -40, and 0, -4. Now let's see how everything works. So let's go inside our main menu scene and let's hit play. So rotation was working fine and everything was working fine. So only thing that is a little bit fast is the animation, but you can directly change it. So let's finally fix that up, and after that our game will be finished. So what we can do is we'll directly change its speed to 0.32, so it doesn't change uh, anything else. And that was it for the game. So let's play and see how it works, and we need to decrease the volume because it's too much high. And let's hit play, and as you can see, you can get the code for this game from the GitHub repo. It is already shared. As you can see, the speed was decreased without changing the parameters. For And the only thing that's remaining is changing our player orientation cause it doesn't look like it's showing good. And let's go inside our prefabs, and not prefabs, uh, gameplay, and let's also rotate the player by 45 degrees. And let's finally place and see the game. And this is going to be final change I am going to make, and after that this game should be finished. So that's it for the game. So this is the game, and as you can see, if you did like how it was created, do like the video and do comment it below how you feel about the code. And if you want more such tutorials, you can follow the channel. I mean, subscribe to the channel. It will help the channel grow, and maybe sometime I'll switch to full time creating videos for YouTube. I mean, maybe someday. So thank you guys for watching if you watched till the end, and see you guys in the another video.